Hey guys, welcome back in my shop, part here in my home machine shop, metal workshop in the north of the Netherlands. So let's talk about Okuma. I had a fork hard chuck that I showed in a previous video. It's a great power manual chuck, but I was looking for an independent 4-jaw chuck as well. But those A16 tapers are quite rare here in the Netherlands. But I found one online with a little bit of help from a friend. Thanks, Lester. Yeah, the chuck itself, it was quite dirty and rusty and had some damage, so I needed to clean it. But then it was time to work on the jaws as well, because yeah, what is a beautiful looking chuck when it's not running through. Yeah, I wanted to take care of that as well. And at the exact moment that I was working on that, I saw an Instagram post by Robin Rossetti about hard turning the jaws and how you can clamp them to cope with the jaw pressure. And I thought, okay, let's do that. I thought about grinding it, but I did had some CBN inserts, or I had one, and I never used CBN before, so yeah, it was interesting to do that. It all worked out great, and yeah, let's show you guys what I did, and let's start with a little bit of cleaning. So this is what the chuck looked like when I bought it, and as you can see, it was quite rusty. Just a quick test fit on the machine, and you can see the size. There was no brand name on there, just this serial number. And yeah, well, the jaws, they did look alright. And it's quite a large one, 355 millimeters. And here it's compared to the Forkat and Rome. And one downside was that it didn't clear the cross slide. And after a lot of elbow grease, rust remover and Scotch-Brite, the chuck is looking good again, and there was even paint underneath all the rust. The screw for the jaws is okay, not the best shape, but still good enough for an independent 4-jaw, and the jaws itself are also quite alright. Then I had a look at the taper and glued it, put it on the spindle, and here you can see there's a little damage point, high point, and a larger one. And I had to remove that to have a good fit. And you can actually see the dent underneath the high point on the face, and that caused the material to push upwards and make this high point. I removed that with the round scraper and then test fit it, and here you can see it runs good enough for this chuck, and also checking the backside to make sure it runs alright before I will turn it down and clean it up. So then it was time to clean the outside of the chuck. Use the WNMG cast iron insert on a very large boring bar. This was the only tool that I had to reach this large OD and all the way on the end, because the chuck didn't clear the cross slide. I was not too happy with the surface finish, but yeah, it was the only tool that I had, so I decided to turn it down until it fit underneath the cross slide, and then I could use a different tool for it. And as you can see, the surface finish was not really good. Different tool, same insert, and bit better surface finish. The stability was a bit better, and it was possible to fit, yeah, clearance is clearance, to fit underneath the cross slide. Surface finish was a little bit better, but I was still not really happy. And yes, I also turned down the screws for the jaws. And the joy of turning cast iron. Surface finish was a little bit better, but still not happy. Used this Sandvik CNMG insert, and that gave a little bit better results. 120 RPM, turning quite slow and steady. And the surface finish was even better. It still looks a little bit rough on camera, but it actually feels quite nice. And yeah, happy with that. So the next step is turning down the face of the chuck. And as you can see, it was quite damaged and rusty. So let's clean that up. Same insert and just put the lathe to work. Now that looks a lot better, so happy with that. Then it was time to hard turn the jaws. I used a bearing race to put some pressure on the jaws, pull them outward, and then turn the face of the jaws. And that actually worked quite nice and gave me a really nice surface finish. And also turned the outside for internal clamping using a different bearing race as a clamping tool to put a pressure on, and that also worked great. So let's talk a little bit about clamping pressure. Remember, I turned it down using the bearing race to pull the jaws outward. This will tilt them a little bit in the movement that there is. So after turning it was straight, but look what happens when I clamp something on the inside. Then the jaws will tilt the other way and there's quite a big movement on the indicator, as you can see here. Rotate the jaws, clamp something on the inside, and then it stays zero again. So the jaws will tilt a little bit inside or outside depending on the clamping pressure. So it's important to use that clamping pressure when you turn down the face that you need for that clamping. Checking it on the other jaw and it's nice and zero again. And the last step is some deburring of the jaws, and I actually like this
diamond knife sharpening tool from Phil Knives. It works quite alright on hardened stuff like this. So yeah, let's take off the sharp corners and then it's good to go. So the chuck is done, guys. Hope you liked it, hope you enjoyed it, and hope to see you next time. Bye bye.